So this chapter is 6A on units of measure. In this chapter, you'll learn about sensible measurements, estimates of measurement, and also the conversions. So in general, here's some key things that you need to understand. There's length, there's area, there's capacity, volume, and there's mass. Now, as we look at length, oftentimes when we measure length, these are the units of measure that we'll see. And if you notice, the common trend is that length is always measured in some form of a meter. So it could be kilometers, meters, millimeters, or centimeters. Now, on your ruler, you'll have all these tiny little marks on there that lead up to 10 finally, and that's a centimeter. So we'll know that 10 little millimeters makes 1 centimeter. And we know that 100 centimeters makes 1 meter, or 1,000 millimeters makes 1 meter. So these are your basic metric conversions, and we'll talk about that in a little bit more. Area is the amount of surface that a space covers. So think about how much, if you're wrapping a present, the area of the front part of the box, that is basically surface that needs to be covered. And often when we measure area, we have square centimeters, square meters, hectares, and square kilometers. And one thing to note, other than hectares, is that when we're measuring area, it's always square something, represented by a little 2 in the quarter of the unit. Now, capacity and volume basically is the amount of liquid inside a 3D container. For capacity, when we see the word volume, it's thinking about air, the amount of space or air inside a 3D container. So we want capacity, we always measure liquid, so how much water goes in, how much juice goes in. Volume is how many rocks can we fit in here, how many pieces of cotton can we stuff in here, how many jelly beans can we put in here. And so when we measure the space within 3D container, we often use milliliters, cubic centimeters, centiliters, cubic meters, or liters. And we'll notice that if it's not talking about liters, which is to measure liquid, we talk about it as a cubic something meters, because it's a 3-dimensional shape. Now finally, mass is your weight. So oftentimes we'll measure mass in milligrams, grams, kilograms, and tons. And as you notice, the trend here, other than tons, is that we measured in grams. So area is often meters, capacity is often liters or cubic meters, and mass is always grams, and length is meters. Area is square meters. So let's go ahead and let's take a look at this first skill, sensible measures. So what we have to do is when we think about objects or when we think about space, we have to have an idea of what a sensible measure means. So for example, if I were to measure my fingernail, I would not use units of kilometers because that's just too big. Kilometers represent distances you're traveling across from one city to another. I would not use meters because, again, that's just, a meter stick is quite long and my fingernail is so tiny. So realistically, when I measure my fingernail, I might use millimeters, maybe even a centimeter with a decimal with it. So this is what this exercise is about. So take a moment here just to read through all the exercise, all examples A through G, and then circle which one across is the most sensible measure. So pause. Okay, so the mass of an apple would usually be about 100 grams. The area of a table would approximately be 1 meter squared. The diagonal length of a computer monitor would most likely be 50 centimeters. And if you think about it, 5 millimeters and 5 centimeters are the same thing, so you can eliminate those two. It's the same thing. The capacity of a can of drink is usually 330 milliliters, which is the same as 33 centiliters. The distance from Madrid to Lisbon is such a far distance, it cannot be meters, it cannot definitely be in centimeters, so it's in kilometers. The mass of a van is quite heavy, and keeping in mind that 1 ton is worth 1,000 kilograms, so 9 tons is 9,000 kilograms. So it would make sense to be that. And the volume of a house brick, and most house bricks are typically approximately 20 centimeters by about 10 centimeters by about, say, 6 centimeters. So if you think about that, that's 200 centimeters times 6, which leads you to 1,200 cubic centimeters. So the closest one to that would be 1,400 centimeters cubed. Now, we're going to work on conversions. Here in the yellow boxes are the conversions that you will have to just start to understand and memorize. But the best way to understand conversions isn't necessarily through memorization, but it's simply the idea of understanding how one thing works to another, like how I understand that 1 centimeter is 10 millimeters. So if I know that when I have to deal with 1 millimeter, I can do the conversion to millimeters and so forth. So if you basically understand your basic metric conversions, this will make it easier. And then area, interestingly enough, if I know 1 centimeter squared is going to be 100 millimeters squared. And the reason is this. 1 centimeter, we know, is 10 millimeters, right? So if we wanted to know what it is squared, we'd actually have to times it by 10 millimeters again, because we need 2 of the conversion. So if I wanted to know 1 centimeter cubed, I would have to go 10 millimeters once for the conversion, 10 millimeters twice for the conversion, and then 10 millimeters one more time for the final conversion, because I need to do the conversion 3 times to get cubic millimeters. And so that's the idea. So that's my recommendation for understanding how conversions work. And you're welcome to ask me more questions in class. But at this time, go ahead and pause and use this table here, or what you understand about metrics, to convert the next 3 problems. Okay, so we know that tons to kilograms, that 1 ton is 1,000 kilograms. So if I know that 1 ton is equal to 1,000 kilograms, I want to know 5.5 tons, into something kilograms. So one way to look at it is I'm going to look from 1 to 5.5. What did I do? Oh, I times it by 5.5. So it's almost like working with ratios or equivalent fractions. So to convert 1,000 to that, I'm going to multiply it by the same scale factor. So this should make 5,500 kilograms. Now we want to convert 6,000 centimeters squared to square meters. And I can simply look at this part right here and say, okay, I know that 1 square meter is equal to 10,000 square centimeters. So if I have 60,000 square centimeters, how many meters squared is that? So again, you could say, well, 1,000 to 6,000, I'm going to times it by 6. So I'll do the same thing, times it by 6. And there you go, we have 6 meters squared. Another way to look at it, as I talked about before, is I know that 6,000 centimeters squared is what I'm trying to convert. So first of all, I'm going to think, how do I convert a basic centimeter to a meter? I know that I have to divide it by 100. Now, because I have square centimeters, I'm going to divide it by 100 twice. So 6,000 divided by 100 twice, well, divide it once, you get rid of 2 zeros. Divide it again, you get rid of the next 2 zeros. So my answer is just 6. So that's another way to look at it. I do the conversion twice because it's square. Now the last one is turning meters cubed to liters. So I see this conversion that 1 meter cubed is 1,000 liters. So 1 meter cubed is equal to 1,000 liters. Okay, so I have 60 meters cubed. So I need to figure out, what am I doing? Oh, I'm multiplying this by 60. So I'm going to do the same thing, times by 60. So that should leave me with 60,000 liters. And that is it.